We are solving Indian Forest Services Mechanical Engineering paper 2 of year 2024. Question number 6b. An ammonia evaporation plant operates between a condensing temperature of 40 degrees Celsius and an evaporating temperature of minus 10 degrees Celsius. The vapor is dry saturated at the end of compression. The properties of ammonia are given below. These are the temperatures in degrees Celsius and enthalpy of liquid in kilojoule per kilogram corresponding to temperature. Enthalpy of vapor is also given, and entropy of liquid is given in kilojoule per kilogram per degree Kelvin corresponding to these temperatures. The specific heat of NH3 vapor is 2.1897 kilojoule per kilogram per degree Kelvin. Calculate the theoretical COP of the cycle. Also calculate the COP of cycle if dry saturated vapor enters the compressor. Draw pH diagram also. So this is the TS diagram and this is the pH diagram. 1, 2, 3, 4 is the cycle, vapor compression cycle. Then the refrigerant is dry at the end of compression. And 1 dash 2 dash 3, 4 is the cycle. Then it is dry at the beginning of the compression. So this is your pH diagram. This is constant pressure line. This is isentropic line. Enthalpy will increase, and this is also isentropic line, and this is isenthalpy line. So here this temperature is 40 degrees Celsius, and here the vapor is refrigerant is dry and saturated corresponding to 40 degrees Celsius. We have enthalpy as 1473. So enthalpy is 1473 kilojoule per kg, and entropy at 2 is entropy of vapor. So entropy of liquid is given, that is 1.36, and this heat can also be calculated, that is 1473 minus 371.5. As is the constant pressure process or constant temperature process, so we divide this difference by temperature, then we get the entropy of vaporization. So entropy of vaporization plus entropy of liquid will make entropy of entropy of vapor. So that is entropy of liquid, and that is entropy of evaporation, or this part entropy. So entropy at this 2 will be your changing enthalpy divided by temperature. So that is 1473 minus 371.5 divided by 276 plus 40. So that comes as 4.879 kilojoule per kilogram per degree Kelvin. So as entropy at 2 and entropy at 1 is equal, but again for this part the entropy of liquid is given, so it means here the entropy is given, that is 0.544. Now we have to calculate the dryness fraction or the entropy corresponding to this entropy, and suppose x1 be the dryness fraction here, then this whole entropy will be change in enthalpy divided by temperature, and temperature here is minus 10 degrees Celsius, and change in enthalpy here is 1433 minus 135.4. So total entropy at point 1 dash, at point 1 is this entropy plus this entropy, that is this entropy plus this entropy, that is 1433 minus 135.4 divided by temperature, that is 263, and for x is, that is total for at this point x is dryness fraction, so multiplying by x1. So this whole part will be equal to this. So from this we can find out dryness fraction, so that is 0.878. Okay. So now H3 is entropy or enthalpy of saturated liquid at 40 degrees Celsius, that is 371.5, that we have used here also, and H3 is equal to H4 because it is vapor combustion cycle. and H1 is, now we have drainage section, we have enthalpy of liquid at at 10 degrees Celsius, and enthalpy of evaporation is 1433 minus 135.4 multiplied by drainage section, so we can calculate H1 also. So 1274.69 kilojoule per kg. So theoretical COP is H1 minus H4 divided by H2 by minus H1. So that comes as 4.552. So that is your first case, theoretical COP. Okay. Don't try to calculate the theoretical COP by assuming it as Carnot cycle. Okay. Because here data are given according data for entropy is given as saturated liquid, not for vapor. For vapor we can calculate by changing enthalpy divided by temperature. If entropy entropy of liquid is given, don't try to make it as T1 by T2 minus T1 Carnot cycle COP. Okay, so that is not theoretical COP, that is ideal COP. Theoretical COP that we are going to calculate. So that is H1 minus H4 divided by H2 minus H1. So it comes out as 4.552. Okay, so that is the theoretical COP in first case, and in second case, this is your dry saturated, and at dry saturated condition for 10 degrees Celsius, H1 dash is 1433 kilojoules we have used here. Okay, and S1 dash is entropy of liquid. X will not be there, X will be 1. Okay, then we take this. So this will come out as 5.477, and entropy of because this is isentropic process, so entropy of 2 dash will be entropy of this 2, that is 4.879 plus this part. So this part entropy is Cp ln T2 dash by T1 T2. So T2 dash is this temperature, T2 is this temperature. So T2 we know that is 273 plus 40, that is 313. So T2 dash we can calculate, that is 411. That comes out as 411.403. Okay. By equating entropy at 1 and 2, we can calculate T2 dash. Okay. So now entropy at T2 dash is T2 dash temperature is known. So we can find out enthalpy at T2 dash. So that is your saturated vapor enthalpy, and that is supersaturated part enthalpy. Total enthalpy at H2 dash is this. Again the COP is the accelerating effect. That is now H1 dash minus H4 divided by H2 dash minus H1 dash. H1 dash minus H4 divided by H2 dash minus H1 dash. So H4 is same. H1 dash we have H2 dash we have calculated, H1 dash we have calculated. So putting this value we get COP as 4.11155.